All right. Go. So 7.3 deals everything with simplifying, multiplying, and dividing rational expressions. For the most part, everything from here on out will be split into 2 days each section. It's going to go definitely out of order. We're going to go like 7. We're going to get multiplying and dividing and simplifying. Then we're going to go to adding and subtracting and just kind of jump around with how the chapter kind of works. And then we'll finish it off with graphing and things like that. But this is your last chapter, and then we are finished. So with simplifying, we'll do simplifying and multiplying today. We'll talk about dividing tomorrow. All a rational expression really is just a fancy name for saying that you have variables with fractions that have variables in them or expressions in them. Okay? If I had 2/7 times 5/3, what would I do whenever you multiply? What do you do with the numerators? What do you do with the denominators? Just multiply straight across, right? So if I multiply straight across, I'm going to go 2 times 5, and I would have 10. I go 7 times 3, and I would have 21, and I would just leave it like that. Now, there nothing canceled before we started. On one like 2, where I have 9/10 times 8/5, you kind of have options. Okay, with any of these, you have a lot of different options that you can go with because you can, for the most part, simplify in some cases, or you can just multiply it straight across. What I would suggest to you is to try to simplify as best you can, because then it's going to make things to where you don't have to simplify. Like, instead of having 9 times 8 and having 72 over 50 and trying to reduce it there, I would change the 10 to a 5 and the 8 to a 4, because what did I do? Just divided everything by 2, right? I think that's a lot easier to do 9 times 4 and get 36 over 5 times 5 and 25. Then I don't have to simplify anything. Okay? I could have went with 72 over 50, and then, but I can't leave it like that because it's not simplified, and then just turn it into 36 over 25. Okay? I'm going to get the same answer, but I think in some cases it's easier for you to just go and simplify first and then multiply or divide. Now, we'll do dividing tomorrow, so we're not going to worry about 3. Even if you have, like on 4 and 5, okay, you still multiply straight across. So if I multiply straight across, this is really just the same thing as 2 times x minus 1, which is just distributing, right? So really I'm looking at 2x minus 2, and then 5 times 5, which is 25, and that would be my final answer. Okay, you'll put everything together. Okay. We're going to kind of, what you'll learn is we'll kind of take it apart and then kind of see what can simplify, then we'll put everything together. Okay. The biggest thing on one like number 5 is that the x's don't necessarily cancel. Okay. Like the x here doesn't cancel with the x there. Okay. You've got to remember that, and that's going to be a silly mistake that'll get made. Okay, because the x on the bottom side of that first fraction in that denominator spot is x minus 1, not just x. Okay, that would be like saying if I had 8 over 7, right, or 8 over 8 minus 1, like I can't just cancel that. Does that make sense? And have a negative 1? Okay. Because they're two totally different things. X and x minus 1 are two totally different parts. So really I'm just going to go x times x and have x squared. And then on the bottom side, now what I would tell you, or what I am going to tell you to do, just leave this as x minus 1 times x plus 1. Don't worry about multiplying it. If it's already factored out, or as a binomial, I don't make you put it all back together. Okay? Now, one thing that I will do is where it says up here in the top, indicate any excluded values. What is one thing we can never divide by? 0. Okay, somebody said it. So if I can't divide by 0, what are the two values that x cannot be on that bottom side? X can't be equal to 1 and negative 1. Why can't x be equal to 1 and negative 1? Because it would make it zero out one of the spots on the bottom. This is why I don't put it back together, is because it makes it easier for students to see, hey, that denominator, I can't have a negative 1, I can't have a positive 1.